Hi there, I'm Ken. Do you have a microwave oven? I guess you have. Most people have got a microwave oven. But have you noticed recently that it's not cooking as well as it used to? Well, maybe the microwave power is decreasing. Now, inside the microwave, right inside, there's a thing called a magnetron, which generates all the energy for the microwaves. As it gets older, this begins to lose its power, just like me really. But how do you know? How can you check if it's working correctly? Well, there are two methods. The first one is a very simple method to say, is it working efficiently at all? The second one is a more detailed method which will allow you to calculate the actual power the microwave is giving. Now, I'm going to show you both these tests. The first one is a very simple one. It just involves a glass of water, like this, maybe about 200 millilitres, which you put in the microwave. Set the timer to 4 minutes. And then press start. And the water inside will heat up. We wait until it starts to boil. Now, this 200 millilitres of water in a 900 watt microwave should take less than 2 minutes. We have to wait till it times down. Time is passing very slowly. Now, when I was younger, I was a dreaded work-study engineer, and people used to say to me, I can't do that job, I've not enough time. And I used to take my stopwatch out and say, well, this is a minute, and I'd time it for a minute. And it's quite amazing, when you're looking for a minute to pass, it takes a long time. When you're looking for this to pass, it takes a long time. Let's see if we can see inside the open a bit. It's very hard to see the glass though, but there it is, and it's gone down 1 minute and 10 seconds so far. Nothing's happening. We just have to wait until the water starts to boil. This should take 2 minutes or less to boil. And you can see how time passes very slowly when you're waiting for it. When you look back, of course, the time's passed very quickly. I look at my years and I think how quickly the time has passed for me. Here we are, it's not boiling yet, and it's nearly 2 minutes. It's 2 minutes now, I think. 2 minutes now, and it's still not boiling. So we have to wait until the water actually bubbles. It's quite hard to see it on the screen here, but I'll tell you when it actually boils properly. We've now got 2 minutes 15 seconds because it's gone down from 4 minutes. It's still not boiling. This is 2.5 minutes now. There's still not any sign of it boiling. Just have to wait. Three minutes and it's still not boiling. So there's obviously something wrong. It should really have boiled around about 2 minutes. Now if it doesn't boil at all, it means the magnetron is not working at all, but it should boil. I'll take a bit more time on. So it's gone 4 minutes now. Still no sign of it boiling. It's just starting to bubble. It's just now starting to boil. You probably can't see it from there. Or can you? No, you can see the bubbles, look. There it's bubbling. And now it's boiling nicely. Now that took more than 4 minutes, which means there's something wrong with the magnetron or the microwave anyway. Okay, so we know the microwave is not very efficient, but how can we work out the actual wattage of the microwave? Well, there is a test. This is devised by the International Electro Industry, I think, Committee, IEC, and it's called the IEC 705. I believe that they have a British standard as well, but if I'm not really sure, I think it's British Standards EN 60705. I've not been able to find much about that. So this is the IEC 705. Again, it's a fairly straightforward test. You need some stuff. You need a nice thermometer, accurate. This is the Thermapen, which is quite accurate. You need 2 containers of water, each containing 500 millilitres. And you need a stirrer to stir the water when you've finished heating it to make sure it's distributed properly. In this test, we measure the temperature of each of these to start with and divide by 2 to find the average. That's the average starting temperature. In the microwave for 60 seconds. We stir it with the stirrer and measure the temperature again of each of the jars and find the average temperature. Then we use a formula, which is the finishing temperature difference minus the first starting temperature, and then multiply by a magic number 71.15. I'll show you that when I do the actual test. So let's measure the temperature first of all. I'm using this Thermapen, as I mentioned, because it's quite accurate. The water temperature is 14.8 in this one and 14.7 in that. So if we take 14.8 as the temperature, it's a bit high. It should be between 10 and 12, or 8 and 12. We'll take that at 14.8. So T1 is 14.8. Put them in a microwave. Timer for 1 minute. So it's timing down for 1 minute, which, as we know, is fairly slow anyway. It doesn't boil, of course, it just heats up. So we need to find the temperature at the end. At the end, we need to stir the water to make sure the temperature is evenly distributed. But that won't be long now. It seems ages when you're waiting, but the test is, of course, must allow some sort of leeway, maybe 5–10%, I don't know, for the testing. But anyway, we'll see, I hope we'll see that this will give a very good idea of the actual wattage of the microwave. This microwave is 10 years old, so it will probably fairly low. There we are. Take the water out a bit, stir it around, and measure the two temperatures. This is 24.2. This is 24.2. So they're both 24.2. So the average is 24.2. So the finishing average is 24.2, which gives us a difference of 9.4 degrees. And if we multiply that by 71.15, we get an answer which is probably around about 700 watts. So it's obviously not 900. So the microwave magnetron will probably need replacing, unless you can find a second-hand one somewhere. But you wouldn't do it yourself. Remember, the magnetron is inside the machine. You must never, ever take the casing off a microwave, unless, of course, you're a completely professional electrical engineer who knows what you're doing. Inside the microwave case, there are lots of voltages hanging around. Even when you switched off, there can be voltages there up to 2000 volts, which could give you a dangerous shock. So do never ever take the casing off a microwave oven unless you yourself are a completely trained professional engineer. Now, I've done this test several times. I'll just show you some results. Here are some results from the test. You can see starting temperature, finish temperature average, starting, finish, average, difference and power. And each time you can see that the average difference is around between 9 and 10. And the power, 711 is maximum. It starts to go down. I know if that's because of getting warm, I don't know. But the power is definitely low at the bottom. So these are some of the results I've taken for testing the power of a microwave. It's not difficult to do. Just remember to get a good thermometer. This Thermopen is very good. I did have another one, one we plug in the oven with comes outside, but I'm not sure about using that in the microwave because it's got metal on it. But this one gives a good result. And you can see anyway that we've tested the microwave first of all with a glass to see it's not working any properly. Then we've found the actual power using the formula from the IEC 705. Thank you for watching.